Hello everyone, I welcome you all to Physics Wala, and in this session we are going to discuss the next portion related to our very interesting chapter of physical chemistry, which is mole concepts. So up to this lecture, whatever we have discussed in lecture 1, 2, 3 are basically theoretical portion. More related to the theoretical portion, we discussed about the laws of chemical combination, we discussed about empirical formula, molecular formula, we know how to deal with the calculation of mole, the concept of limiting reagent, and how to apply mole analysis. Now in this particular session, we are going to discuss much more interesting facts about this particular chapter, and basically in this session, we are going to discuss some important concepts related to concentration terms, and mainly we are going to focus on mass percent, molality as well as mole fraction. Along with that, we are going to discuss some other portions also related to concentration terms like volume percent, like mass by volume percent, like ppm as well as ppb. I hope up to that part everything is clear. If you guys have any doubt, just let me know in the comment box. We will discuss that particular part. Now basically in this session we are going to discuss about the concentration term. Along with that, we are going to practice some important questions which are your previous year questions, or I can say from your NCERT book itself. Okay, so let's start. So basically if I talk about the concentration terms, in that case the first term is actually mass percent, but the thing is how to deal with the term concentration terms. So basically we have a particular part which is known as solutions. So you know that if I talk about the solution is nothing but I am talking about the homogeneous mixture in that case. So solution is nothing but a homogeneous mixture. And generally in this particular case, homogeneous mixture means if I am mixing, let's say, two components, in that case after mixing there is no boundary separation between these two components, that is the homogeneous mixture. And in this case we are talking about the binary solution. In this case we are more focused on binary solutions, means I am talking about two components in a particular mixture. So in that case you have two components. Component 1 is actually known as a solute and component 2 is actually known as solvent. Okay, how to deal with this particular part? What is solute, what is solvent? It's very easy to understand. Generally we actually get this information slightly misleading. So let me tell you the basic idea about the solute and solvent. We generally know that the component which is present in lesser amount is actually known as a solute, and the component which is present in more amount is actually known as a solvent. But the amount, in that case we are talking about the number of moles. If we have less number of moles, definitely we are talking about solute. If we have more number of moles, definitely we are talking about the solvent. And binary mixture means we are talking about two components in a particular solution. So I can say that solution is nothing but a mixture of solute plus solvent. I hope this part is clear. Always remember this particular equation because this will be very helpful when you are dealing with the calculation of moles. Now in that case, if I talk about the concentration terms, we are talking about the concentration of a solution. What is the meaning of concentration of solution? It's very easy. So basically I am talking about the concentration with respect to the amount of solute with respect to the entire solution. So whatever amount of a solute is present in the given amount of solution, that actually represents the concentration. And in that case we have different type of expressions to express that concentration. And in that case the classification consists of two parts. First one is temperature dependent concentration terms, and next one is temperature independent concentration terms. You all know like what is the meaning of temperature dependent concentration terms. So all those concentration terms which are actually temperature dependent, it means their value is going to change if I am changing the temperature. And just note down one important point. Always remember all those concentration terms in which volume is actually included, it means they are temperature dependent in that case. If I talk about the temperature independent concentration terms, I can simply say all those concentration terms in which there is no correlation with the volume. It means either you are dealing with number of moles directly or you are dealing with the weight part. In that case they are not going to change with temperature. So those are actually known as temperature independent concentration terms. Okay, now if I talk about the first part, we have a mass percent. So in this case always remember we are comparing solute with respect to solution. So what is the definition? How you are going to define that particular part? It's very easy. The amount of a solute, because we are dealing with mass, it means I am talking about the mass in grams. So I can simply say the amount of a solute present in grams. which is definitely going to be present in grams with respect to 100 gram of a solution, or I can say the mass of solute in grams present in 100 gram solution is actually known as mass percent, and it is actually represented by percentage W by W. Okay, so basically we are comparing mass with another mass. Definitely this particular part is going to be temperature independent. This concentration term is going to be temperature independent. Okay, first part. Next thing is, what is the formula in that case? It's very easy. You can simply say that percentage, mass percentage or percentage W by W is basically W of solute, which is in grams, definitely, divided by the W of a solution, which is again in grams, multiplied by 100, because we have to calculate the percent in 100. Okay, so in that case I can simply say the formula is very easy to understand, and definition is also very easy. This is the first part. Now I can play with the variations of this particular part. I can talk about percentage volume. So in that case, if I talk about the volume percent, again in this case I am comparing solute with respect to solution. Okay, so there are certain terms, concentration terms, in which you are going to deal with the solute with respect to solvent. Other than that, in mostly cases you are going to deal with the solute with respect to solution. So percentage volume by volume or percentage V by V, in that case you can say that amount of solute in ml which is present in 100 ml of solution is actually known as your volume percentage. Definition is already given to you. You can just simply look at it. But the formula in that case is very easy, just like the percentage M by M, in that you can say percentage V by V will be equal to V solute, which is again in ml, divided by V solution, which is again in ml, multiplied by 100. Now in this case you can see we have inserted the volume part. Definitely this particular concentration term is going to be temperature dependent in nature. So this particular part is basically your temperature dependent. I hope this entire part is clear to everyone. Okay, just like that I can talk about another concentration term, which is percentage mass by volume. So in that case again it's very easy, W by V percent I can say. In that case always remember the amount of solute which is in grams present in 100 ml solution is actually known as your mass by volume percentage. Okay, so that will be your mass by volume percentage. So that will be mass by volume percentage. The formula in that case is again going to be very easy. We are talking about percentage W by V. It means W of solute, which is definitely in grams, divided by the V of solution, which is in ml, multiplied by 100. Again in this case you can see we have the term of volume. Definitely this concentration term is going to be temperature dependent in nature. So these are three same type of concentration terms. I am expressing the concentration in different units. I am either considering volume, I am either considering mass, or I am considering mass by volume. I hope the entire part related to these three simple concentration terms is clear to everyone. You can correlate these concentration terms with each other very easily. Just remember certain informations. I told you that whenever we talk about solution will be equal to solute plus solvent. Just remember this particular information. And next thing is density will be equal to mass per unit volume. Always remember these two formulas. They are very important whenever we talk about the change in the concentration terms, because you can convert one concentration term into another one. I hope this part is clear. Now let's talk about a very simple question related to all the concentration terms altogether. Okay, question says 40% by mass of urea is obtained when 100 gram of urea is dissolved in enough water to make 100 ml solution. The density of the solution will be. A very interesting question. Either you can start with very simple questions related to each and every part. If you want, I can give you one question each to practice about each concentration term separately. Okay, so let's start with the first part. If I talk about this concentration term, the question is going to be very easy. Let's say calculate percentage W by W of solution having 15 gram sucrose in enough water to make 50 gram solution. Very simple question. So in that case you can see that percentage W by W will be equal to amount of a solute, which is 15 gram, divided by amount of entire solution, which is 50 gram, multiplied by 100. So you can see that will be 30%. I hope this part is clear. Very simple question. Very simple question. Now in the same way, if I talk about the next part, let's say question says calculate percentage V by V of solution formed by mixing, let's say 18 ml of ethanol with, let's say this is 32 ml of water. Okay, so question is saying that calculate percentage V by V of solution formed by mixing 18 ml of ethanol with 32 ml of water. Now you know this is the amount of solute, this is the amount of solvent. So always remember, I told you that V of a solution will be equal to V of solute plus V of solvent. That's why I told you, always remember solution will be equal to solute plus a solvent. So if I am putting this particular part, I know that V of a solution will be equal to 18 plus 32, that will be 32 40 50, this is 50 ml. Okay, now I know the amount of solution, I know the amount of solute. I can simply say that percentage V by V will be equal to, we have first part which is 18 divided by 50 multiplied by 100, so that will be 36%. I hope this part is clear. Very simple question, again very simple question. In the same way you can change the information in this particular part. You can deal with amount of solute, which is in basically grams divided by the total volume in ml, and then you can deal with the same question. Now coming back to the same problem, in this particular part, first information which is given to us is the data about percentage by mass. So in this case percentage W by W is given, which is 40%. This particular part is already given to us. Okay, now by mass of urea is obtained when 100 gram of urea, it means W of urea is given, which is 100 grams, but W of a solution in this case is missing. We don't know that particular part, because it simply says that it is dissolved in enough water to make 100 ml solution. We know one thing, that volume of solution in this case is actually 100 ml. But again, from this information, this has no use. So I can put the formula of this particular part. I can say that percentage W by W is equal to W of a solute, which is urea in this case, divided by W of a solution multiplied by 100, and both are in grams. So I can simply say this value is given, which is 40, will be equal to 100 multiplied by 100 divided by W of solution. Okay, this part is unknown to us. So from that part we can say that the W of a solution will be equal to 100 multiplied by 100 divided by 40. So this information we have already calculated. Now you can see volume is also given, and the question is asking about the density part. Density of a solution will be equal to W of solution divided by volume of solution. Everything is already given to us. So we can say W of solution is 100 multiplied by 100 divided by 40, and this entire part is divided by the V solution, which is 100 ml. So we can say that is 100. So I can cancel out this particular part. 2.5 gram per ml. Is there any option? 2 point, yes, definitely we have the option which is 2.5 in this particular case. Very simple question, just look at it, just understand the calculation, and that's it. Very simple question. From percentage, mass by volume, percentage by volume, everything is already given to us. Okay. Now, talking about the next part, let's talk about a very interesting concentration term which is molarity. Now we know about the percentage calculation. It's time to understand the basic idea about the molarity. So again we are talking about the molarity of a particular solution, in which we have again three components. First one is basically solute. First part is basically your solute in this case. Next part is basically the solution, and last part we know we are talking about the molarity concentration term. It means I can simply say this is the same type of concentration terms in which I am comparing solute with respect to solution. So again the same type of concentration term, solute with respect to solution. How to deal with this particular part? It's very easy. Now in this case I am expressing solute as a number of moles, and in this case I am expressing solution as the volume of solution. Okay. So definitely in this particular part I am making a solution having lesser amount of solute and more amount of solvent, which is basically a binary solution. And three things again are related to each other: concentration term, solute as well as solution. So how to define this particular part? It's very easy. We can say molarity of any solution is basically the number of moles of solute which are present in 1 liter solution. Always remember the concentration term is a very interesting, that is molarity of the solution is defined as the number of moles of solute which are present in 1 liter solution. So how can we define this particular part? We can express the formula in two terms. Either I am taking the volume in liters or I am taking the volume in milliliters. If I am expressing the volume in liters, I can simply say capital M, which is the representation of molarity, will be equal to number of moles of solute divided by the volume of solution in liters. Now if I am changing this volume of solution in ml, then I need to multiply the entire part with 1000. So I can say these are the two formulas related to molarity. Now remember one thing you have to understand from this particular part. We already know that mole can be expressed in different terms. Either you can talk about given weight divided by the molar mass of that component. You can talk about the number of particles of a species divided by the Avogadro's number. You can talk about the volume of gas in liters at STP divided by 22.4 liters. But another formula in terms of molarity, you can say from that particular part that number of moles of a solute are basically molarity of the solution multiplied by the V of a solution in liters. I hope this part is clear to everyone. So there is another formula which is very important and very relevant when we talk about the calculation. Another part, let's say we have the molarity of a solution, but in this case we have a volume of solution in ml. So always remember, when the volume is in ml, we are talking about the millimoles of solute. So these are the two things which you have to understand whenever you are dealing with the questions of moles. I hope this entire part is clear. Both the equations are very important when we are going to talk about the calculation part. I hope everything is clear to everyone. Now next thing is, okay, so we have one question. Question says calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. Molar mass of sodium acetate is already given to us. So this question is basically from NCERT. So we have to calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. So first of all, just write down the information which is given. So molarity is given, which is 0.375 molar. Molar is the unit in this case. Okay. Next part is volume of a solution is already given, which is 500 ml. Okay. The information which is missing in this particular case is number of moles of solute. They are missing. Can I apply the formula of molarity? Yes, definitely. I can say that molarity is equal to number of moles of a solute divided by the volume of a solution, which is in ml, multiplied by 1000. I hope this part is clear. Now in this case, this N solute, the solute is basically sodium acetate. This particular part is sodium acetate. Can I put the value? Yes. 0.375 will be equal to number of moles of solute divided by volume of solution, which is 500, multiplied by 1000. So I can say this part is going to be cancelled out by 2, and a number of moles of sodium acetate, which is our solute in this case, will be equal to 0.375 divided by 2. So number of moles are already done. Now you know one formula, that number of moles are W or divided by M. This part you already know, that number of moles of any solute will be equal to given weight divided by the molar mass. Now in this case you can say W of sodium acetate, we don't know, but we know about the molar mass. Molar mass is already given, which is 82.0245. 82.0245 is given, will be equal to 0.375 divided by 2. So from that particular part, we can say that W of sodium acetate, we can say that W of sodium acetate will be equal to 0.375 divided by 2 multiplied by the entire amount. You can say, okay, I am writing it another side because it's too much crowded. So I can say that will be W of sodium acetate will be equal to 0.375 divided by 2 multiplied by 82.0245. So what you have to do, just solve this entire part and let me know the final answer. Okay, so let me know the final answer in comment box. That will be your homework. Very simple question related to molarity, but molarity concept is very wide actually. We can talk about the molarity in case of dilution, we can talk about the molarity in case of mixing. We are going to discuss that part also, don't worry, because it may be possible that I am mixing 2-3 solutions all together to make a final solution. In that case, either a certain reaction is happening or both the components are same or having different volume. So in that case, either we can use the concept of dilution or we can use the concept of mixing. Okay, I hope this question is clear to everyone. Very simple question. Just write down the information which is given to you, try to apply the formula, find out the unknown missing link, and then we can proceed for the answer part. I hope this entire portion is clear. Now let's talk about, okay, so we have another question which is again from molarity part. This question is very interesting. Calculate the concentration of nitric acid in moles per liter. If the information is given in moles per liter, it means the question is asking about the molarity part. Okay, in a sample which has a density 1.41 gram per ml and the mass percent of nitric acid is being 69%. Now this question looks slightly typical, but the information extraction is a very easy in these type of questions. First of all, you can see that percentage W by W is given, percentage W by W is given, which is 69%. You know that the density of solution is also given, which is 1.41 gram per ml. Now the question is asking about the molarity of the solution, which is basically number of moles of a solute divided by the volume of a solution in liters, or you can say, let's say in ml multiplied by 1000. Can you expand the formula? Yes, definitely we can expand the formula. That will be W of a solute divided by the molar mass of a solute multiplied by the V of a solution in ml multiplied by 1000. Okay, or I can say from that particular part, that molarity of the solution will be equal to W of a solute divided by the molar mass of a solute. Okay, then volume of the solution, you can use the formula of density in that case. That density is equal to mass per unit volume. Now volume will be given weight of the solution divided by the density. So you can say that will be W of a solution divided by the density of the solution multiplied by 1000. Again I am going to rewrite it. That will be W of a solute divided by the W of a solution, let's say, multiplying by the 100. Why I am doing this? I am expanding this 100 multiplied by 10. So multiplied by 10 multiplied by the density of a solution, then divided by the entire part, which is the molar mass of the solute. Okay, now you can see we have a specific concentration term. This is percentage W by W, that is the amount of solute in grams present in 100 gram solution. So this particular part is already a concentration term. So this will be percentage W by W multiplied by 10 multiplied by the density of a solution divided by the molar mass of solute. That will be the molarity. So either you can use this particular formula, So this is a simple conversion of one concentration term into another one. I am converting percentage W by W into molarity. You can easily see. But the thing is, in questions or in exam paper, sometimes we miss the formula. We don't actually remember the exact formula. So in that case, I am going to give you one simple trick which you can apply to understand the entire concept. If you don't know anything, just try to apply that trick. That trick is 3 by 3 box. Okay, so very simple trick, but otherwise you can see the conversion part. It's very easy. I am just expanding the formula to convert one concentration term into another one. So there is a relation of molarity with percentage W by W. I have also written that particular part in the relations, but I am just giving you one basic idea about the conversion part. Okay, now you can directly put the values and let me know the answer. But other trick in that case, what you have to do, you just have to make a 3 by 3 box. A very simple box. So this is the first part. Okay, this is the second part. Okay, first part, second part. Okay, so you can see we have a 3 by 3 box. So what are the informations you have to write down? First of all, that box is solute, that is solvent, and that is solution. First part. Next part is weight, volume and density. So just write down all the informations which are given. First information is percentage W by W is 69%. What is the meaning of this particular term? It's very easy and it's very important to understand the meaning of each concentration term. It means you can say that 69 gram of solute is present in 100 gram solution. So from that particular part you can say W of solute is given, which is 69. Next part is 100 gram of this given already. Now next thing is you can see density of solution is also given, which is 1.41 gram per ml. So density is 1.41 gram per ml also given. Now from that particular part, can you calculate the volume? Yes, very easy. 100 divided by 1.41 will be the volume of solution, because we know that density is equal to mass per unit volume. Mass is given, density is given, volume will be 100 by 1.41. So that part is clear. Now for molarity, you need number of moles of a solute divided by the volume of a solution in ml multiplied by 1000. Now you know this information is already known to us, but this information is missing. So from that particular part we can say number of moles of our original solution is basically nitric acid. So we can say number of moles of HNO3 will be W of HNO3 divided by the molar mass of HNO3. Okay, so we can say that will be 69 already given to us divided by molar mass of HNO3. So nitrogen is 14 plus 1 15, then we have 48, so 48, then we have 49, then 63, that will be 63. So now we know the number of moles, we know each and every situation. What can we do? We can just place the values. So number of moles of solute is 69 by 63, then multiplied by 1000, then volume of solution is 100 divided by 1.41, so 1.41 here. Now if you solve this, you will get the value as 69 multiplied by 10 multiplied by 1.41 divided by 63, same value. Now put the values here. Now put the values in this formula. You can see we have same value. Percentage W by W is 69% multiplied by 10 multiplied by density 1.41 divided by the molar mass of solute, which is 63. So you can see both the values are coming as same. So if you are not able to remember this direct conversion, you can use this 3 by 3 box. Try to fill the boxes with all the informations given and whatever you have calculated, but try to understand the actual meaning of each and every concentration term. I hope this entire part is clear. You can just solve this entire part and let me know the final answer. So again I am giving this as homework. Okay, I hope up to this part everything is clear to everyone. Very simple situations, very simple concept also. Okay, now talking about the next concept. Again we have a question from the examination JEE main. Question says 29.2% W by W HCl stock solution has a density of 1.25 gram per ml. The molecular weight of HCl is 36.5 gram per mole. Molar mass is given. The volume of stock solution required to prepare a 200 ml solution with 0.4 molar HCl is. So very interesting solution, because from the stock solution we are preparing another type of solution. So in this case you have to understand first of all the data about the stock solution. So you have to calculate the actual molarity of the stock solution. So in that case what can we do? We can directly use the formula, or you can make the 3 by 3 box. So 3 by 3 box I am giving to you as a homework. I am just putting the formula that molarity of stock solution will be equal to percentage W by W multiplied by 10 multiplied by the density of a solution divided by the molar mass of solute. In this case the solute is basically HCl. Solute is HCl. Every information is given. So the molarity of stock solution will be equal to, this is 29.2 multiplied by 10 multiplied by density is given 1.25 divided by molar mass of solute. You know molar mass is 36.5 already given. So this is 36.5. So this is the first step of the solution. This is the first step of the solution. This is the first step of the solution. This is the first step of the solution, which is the molarity of stock solution. Because in this case, let's say I have, how can you understand? It's like formation of roux afza solution, that particular refreshment roux afza which we generally use, or rasna, whatever it is, you can consider. You can consider the fresh lime soda in that case. So you have a stock solution which is very concentrated, which has maximum amount of solute, and then you are taking 2 tablespoon or 3 tablespoon of that stock solution and mixing it with water, then making the actual solution. So that is the concept here we are using, because in the final case everything is given. We have 200 ml solution, we have 0.4 molar HCl, we have to make this particular part from the stock solution. from the stock solution which is highly concentrated. So for that particular part, we need to use another concept, which is the molarity of a mixing or molarity of dilution. So first of all, we are going to deal with that particular part. How can we deal with the molarity of dilution? So in this case, I am talking about the concept of dilution. What is the meaning here? Concept of dilution. It means I have one solution. So this is the original solution. This is the original solution before any addition. So in this case, let's say its molarity is M1 and volume is V1. This is the stock solution. Okay. Now in this stock solution, you can see that we have lower volume, but the amount of these solute is actually very high, which is the stock solution. Now let's say I'm putting certain amount of solvent addition. It means I'm using the concept of dilution. Dilution means I'm adding more amount of solvent in the given solution. Okay, so I'm adding solvent in this particular part, and finally after adding the solvent, now the molarity becomes M2 and volume becomes V2. Okay, after that particular part, but you can see a slight change. You can see the increment in the volume, and these solute parts are actually less. But always remember, if I'm adding the water in the particular solution, whatever number of moles of solute are present initially, they are going to remain as it is after the addition of water. It means you can say that before dilution, whatever number of moles of a solute are present, they are actually equals to number of moles of a solute after dilution, because I am not changing anything. I am just adding water. So let's say I am using sugar solution. So in sugar solution, we have sugar and water. I am adding more water, so there will be no effect on sugar. The amount of sugar or the number of moles of sugar which are present initially, they are going to remain as it is after the solution formation. So you can see in this particular case, now I am going to use the formula of molarity. I told you one formula of molarity. Just look at this formula. I told you that number of moles of solute are basically molarity of the solution multiplied by solution volume in liters or in ml. So again, I am using this particular part here in this concept, which is the concept of dilution. So nothing fancy here. We can say that M1 V1 will be equal to M2 V2. Always remember this particular part for dilution concept. Just look at it. So before dilution, the stock solution has molarity M1, volume V1. After the formation, they have M2 and V2, molarity as well as volume. But their number of moles are remain constant. It means before dilution, number of moles are actually equals to number of moles after dilution. M1 V1 will be equal to M2 V2. Now I can use this concept here, because we know that the volume of a stock solution required to prepare a 200 ml solution of 0.4 molar HCl is that we have M2, which is 0.4 molar, V2 will be 200 ml. Okay, M1 we already know, which is 29.2, or I can say this is basically your M1. But V1 we don't know, V1 is missing. So we can say that M1 V1 will be equal to M2 V2. Can I apply this concept? Yes, definitely. So we can say that we have 29.2 multiplied by 10 multiplied by 1.25 divided by 36.5 will be equal to, multiplied by V1, which is missing, will be equal to M2 is 0.4 multiplied by 200. So what you have to do, you just have to solve this entire part. That will be 0, cancel out with this 0, this decimal cancel out with this particular part. You have a V1 will be equal to 0.4, 4 to the 8 multiplied by 36.5 divided by 29.2 multiplied by 1.25 ml. That will be your final answer. Okay, I can write down the answer, but it will be much feasible for you to solve the entire question and then find out the final answer. Okay, I will let you know the actual answer of these questions in the next class. Okay, so that will be in ml. Okay, and that's how you can deal with these type of questions. Very simple question, but again the language is slightly typical, so don't be afraid. Just read out the question, understand the concept, whatever we have to use in that particular question, and apply that. Okay, so that is your concept of dilution. I hope this part is clear. Now it may be possible that we have two different solutions having same type of solute. So when I'm mixing those solution and I'm making a final solution, what will be the molarity in that case? That is basically the molarity of mixing. We are going to discuss that part also in the next upcoming concept. Okay, now the question says find out the volume of 98% W by W H2SO4 must be diluted to prepare 12 liters of a 2.4 molar sulfuric acid solution. So in this particular case, again we have molarity of solution which is equal to percentage W by W multiplied by 10 multiplied by the density of a solution divided by molar mass of solute. Okay, now in this case we know solute is H2SO4. Solute is H2SO4. So what I'm doing, I'm calculating the molarity of stock solution first. Okay, which is equals to percentage W by W is 98 multiplied by 10 multiplied by density is 1.8. Okay, divided by the molar mass of solute which is again 98. So we can say the molarity is 18 molar. This is the molarity of stock solution. Now the given information is that M2 is given which is 2.4 molar. V2 is given which is 12 liters. M1 we have calculated. This is the M1 stock solution which is 18 molar. So I can again apply concept of dilution. I can apply the concept of dilution and I can say that M1 V1 will be equals to M2 V2. Okay, from that part I can say that 18 multiplied by the V1, the volume of stock solution, will be equal to 2.4 multiplied by 12. So V1 of the stock solution will be equal to 2.4 multiplied by 12 divided by 18. So that will be 0.8. That will be 1.6 liters. Now if you are writing the answer as 1.6 liter, it's incorrect, because the question is asking that find out the volume of this much solution. This solution must be diluted to prepare 12 liter of a 2.4 m sulfuric acid solution. So the initial solution volume was 1.6 liter and we have diluted it up to 12 liters. So how much amount of water is required? You can say the final volume is 12 liter, the initial volume was 1.6, so 12 minus 1.6, that much amount of water should be added to convert the entire part into 12 liter of 2.4 molar sulfuric acid solution. So that will be your final answer. One additional step, you just have to know about the amount of water which is required to actually prepare this final solution. Okay, I hope this entire part is clear. If somebody asks how much stock solution volume is required, so that is 1.6 liter. If somebody asks, tell me the volume of water required to add in this situation to convert it into this final molarity, you can say the final volume is 12 liter minus initial is 1.6, so that will be 10.4 liters of water should be added in this solution, which is 1.6 liter of 18 molar solution, to convert the entire part into 2.4 molar 12 liter solution. I hope this entire part is clear. The concept is clear. So In this case, this question is asking about this amount only. It may be possible that question is asking about the amount of water which should be added to dilute the entire solution. So in that case, you can use additional step here. I hope this entire part is clear. Very easy, very interesting question again from molarity part. Okay. Now talking about the next question, the molarity of a solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. Now in this case, you can see that solution 1 is actually HCl solution, and you can see that solution 2 is again HCl solution. So I told you that we have a specific concept, that is the concept of mixing, in which solute is actually same. So how to deal with the questions related to this particular part? In that case, we know that in that case we need to use the concept of mixing. We need to understand the concept of mixing. Note down that important point, whatever I am going to say, the concept of mixing. So in this particular case, let's say I have one container having HCl. Okay, in this case its molarity is M1, volume is V1. So we can say that number of moles will be equal to M1 multiplied by V1. That will be the first part. And I am mixing it with another solution of HCl, same component. This is component 1, this is 2, and in this case its molarity is M2 and volume is V2. So its number of moles are N2, which are equal to M2 multiplied by V2. Okay. Now I am mixing these two solutions to form the final solution. Okay. In this final solution, let's say molarity is M final and volume is V final. When I'm mixing these two components together, I can say that V final is actually V1 plus V2. Very easy. That final volume will be the mixture of both the solutions, V1 as well as V2. So final volume is clear. Now number of moles which are final are basically their number of moles as well as their number of moles, the addition of both the number of moles. So I can say that will be N1 plus N2. Okay. Now I know from that particular part that molarity final will be equal to number of moles final divided by the volume final. So I can put the values. Here. So that will be your N1 plus N2 upon V1 plus V2. Either I can use this formula or I can expand N1 and N2. So I can say that will be M1 V1 plus M2 V2 divided by V1 plus V2. Just remember this particular formula. Whenever you are dealing with the volume. Okay, so that will be the M final. So you can use this formula M1 V1 plus M2 V2 divided by V1 plus V2. So this is the concept of mixing. Now in this particular case, you can see that we have solution 1. In this case, M1 as well as V1 given. So the molarity of solution obtained by mixing 750 ml and 0.5 molar. So we have 0.5 molar and 750 ml on this side. For this situation, M2 and V2 are also given. M2 is a 2 molar. So we have 2 molar and V2 is 250 ml. 250 ml. Okay. So now put the value that M final will be equal to M1 V1 0.5 multiplied by 750 plus V1 M2 V2, which is a 2 multiplied by 250 divided by the entire part V1 plus V2. So 750 plus 250. So I can say that will be, this is going to be cancelled out with this particular part, and then we have 375 plus 500 divided by 1000, that will be 875 divided by 1000, or I can say 0.875 molar. Is there any answer? 0.8, yes, we have option number D, which is 0.875. So you can use the concept of mixing as well as concept of dilution in case of molarity. That's why the concept of molarity is a very, very vast concept. Okay, I hope the entire part is clear. Very simple question. Okay, now talking about the next part, if the density of methanol is 0.793 kilogram per liter, what is its volume needed for making 2.5 liter of its 0.25 molar solution? Again the same question, this is from NCERT basically. So we know that we have the density as well as the volume needed for making 2.5 liter of its 0.25 molar solution. Okay, now in this case density of methanol is given. Okay, what is its volume needed for making 2.5 liter of its 0.25 molar solution? Okay, so what can we do? What is its volume needed for making 2.5 liter of its 0.25 molar solution? So this is definitely the idea about the stock solution given. This is the idea about the stock solution given. And in this case I can say final solution is given, that we have M2, which is 0.25 molar given, V2 is 2.5 liter given. So this part is given. Now the question is asking, if the density of the methanol is this much, what is its volume needed for making? So in this case we have to calculate M of stock solution, we have to calculate this entire part, and V of stock is missing in this situation. V of stock solution is actually missing in this particular situation. So let's say the density of methanol is given, which is 0.793 kilogram per liter. Okay, this entire part is given to us, which is the density. Now to calculate the molarity of stock solution, we need W of methanol divided by let's say W of methanol divided by the molar mass of methanol multiplied by the volume of solution, okay, that is actually required in liters, let's say. Okay, so this is the entire part which is required in this particular situation, that W of methanol divided by the M of methanol, which is the molar mass of methanol, multiplied by the V of solution. Now you know, from that particular part we know that methanol is basically CH3OH, that is methanol. So if I talk about the molar mass of methanol, that will be 12 plus 15, 116, 16 plus 16, we have 32 gram per mole. That is the molar mass of methanol. Now from that particular part we can say, in the methanol solution, in 1 liter solution, in 1 liter of that particular part, we have this much kilogram of methanol. So from that particular part we can say that in 1 liter solution, 0.793 kilogram methanol is present. Okay, in 1 liter solution 0.793 kilogram of methanol is present. It means W of methanol is clear, molar mass we already know. In 1 liter it means volume of solution we have taken 1 liter, so we can say that M of stock solution will be 0.793 kilogram, means 793 grams divided by 32 multiplied by 1 liter basically. Okay, so that is the molarity, in this particular situation, multiplied by 1. Okay, so this part is clear. So you can say, yeah, that will be the molarity, which is 793 by 32. You can solve that particular part, that will be in molar. Now you know that M stock is already been calculated. V stock is unknown to us, that how much amount we have to take. So we can say that M1 V1 will be equal to M2 V2. This is for stock, this is for diluted version. Okay, so for stock we know that we have 793 divided by 32 multiplied by V of stock, which we don't know, will be equal to 0.25 multiplied by 2.5. So we can say from that particular part that V of stock will be equal to 0.25 multiplied by 2.5 multiplied by 32 divided by 793. That much liter of the stock solution will be required to form the final solution. So I hope this entire part is clear. Every question is almost same in this particular scenario. Okay, I hope this portion is clear. You can look at it carefully and just let me know the final answer. Just understand the concept and let me know if you have any issue. Okay, now let's talk about the next portion. Which is the concept of molality. Now remember, this is a very interesting concentration term, because in this particular case I am actually expressing the relation, or I am comparing solute with respect to solvent. So you can see this is the only one where I am comparing solute with respect to solvent. Now in this case, the molality, which is represented by a small m, is basically the number of moles of solute which are present in 1 kilogram solvent. So in this case, you can see again we have a weight and number of moles, both are temperature independent. So definitely this concentration term is temperature independent. Okay, so this is temperature independent concentration term. Now in this case, the formula is very easy, that a number of moles of solute with respect to the amount of solvent in kilogram. So again, two formulas, either you can express mass in kilogram or in grams. So if you are using in kilograms, so N of solute divided by the W of solvent in kilograms, or in this case N of solute divided by the W of solvent in grams multiplied by 1000. So that is a small m, sorry for the typo error. So this is a small m. So you can see there are two formulas related to your molality, and unit in this case is again going to be molal. Okay, I hope this part is clear. Let's talk about one question. Question says, calculate molality of each ion present in the aqueous solution of a 2 molar NH4Cl, assuming 100% dissociation according to the reaction. Very interesting question, slightly large calculations, but overall idea is very easy. And density of the solution is already given, which is 3.107 gram per ml. Now either you can use the concept which I told you, that you can make a 3/3 table, then write down the entire formulation, or you can use the direct relation. So the direct relation part will be coming in the next slides, but first try to solve the entire part with the help of 3/3 box. Will it be applicable or not? Let's find out. So we have first part, Okay. 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 Now in this case we have solute, we have solvent, we have solution. Here we have a weight, volume and density. Now density of solution is 3.107. 3.107. Now next part is 2 molar NH4Cl. Molarity will be 2 molar. What is the meaning of this term? What is the meaning of this particular term? It's very easy. You can say from the definition itself, that 2 moles of NH4Cl are present in 1 liter solution. So if you have a 1 liter solution, it means this value is 1000 ml. Now what you have to do, 1000 ml multiplied by 3.107, that will be 3107 grams of solution. Density formula, density is equal to mass per unit volume. So this part is already known to us. Now from this 2 moles of NH4Cl, can we calculate next information? Yes, very easy. We know that molar mass of NH4Cl, is it given? I don't think so. So NH4Cl, we have nitrogen 14 plus 14, 18. So this particular part is 18 plus chlorine 35.5. So that will be that will be 0.53 and 53 gram per mole. So this is 53 gram per mole. Okay, so we have calculated this particular part. So 35, 45, 53, yeah, 53.5 gram per mole. Now 2 moles of NH4Cl are present. It means number of moles of NH4Cl will be equal to W of NH4Cl divided by molar mass of NH4Cl. So we can say that 53.5 multiplied by 2 will be equal to W of NH4Cl. So we can say that will be 5 2s are 10, 1, 6, 7, 10. So 107. That will be 107. So now we know everything. So from that information, this is very much required. This is grams of WNH4Cl already been calculated. Okay. Now the next part, I told you that solution is equal to solute plus solvent. So I can say W of solution will be equal to W of solute plus W of solvent. This particular part, you know W of solution, which is 3107. You know the W of solute, which is 107. So that will be 3000 only. That's it. Now we can say that molality will be equal to number of moles of a solute divided by the W of solvent in grams multiplied by 1000. Number of moles of solute, 2 moles of solute are present. So I can put the value here, which is a 2 divided by 3000 multiplied by 1000. So these are cancel out. We have the value 2 by 3 molal. That will be the final answer. So you see, the application of this 3 by 3 box is amazing. You can actually calculate each and every part, whatever missing in this particular link. Okay, but remember, like this information is pretty much required to understand the concept of 3 by 3 box. I hope this entire part is clear to everyone. Okay, now talking about the next question. Okay, next concentration term is very easy, which is parts per million. Again, in this case, I am comparing solute with solvent part. Either you can talk about the grams, either you can talk about the ml. But the meaning is a part per million, which is ppm, is a one part of the solute with respect to the millionth part of the solution. Okay, so the idea is very easy, that whatever mass of solute is given in grams divided by the mass of solution given in grams multiplied by 10 raised to the power 6 will be your ppm. That will be your ppm. Or if the term is given in terms of volume, you can again use the same formulation, which is volume of solute in ml divided by the volume of volume of solute in ml divided by the volume of solution in ml again. So that will be either in ml as well as in ml. So there is one important term also, which is ppb, parts per billion. So instead of using 10 raised to the power 6, you can use 10 raised to the power 9. That will be for parts per billion. I hope the entire part is clear to everyone. Very, very simple question. Okay. Now, 0.4 gram CaCO3 is dissolved in 100 kilogram of water. The impurity of CaCO3 in ppm will be. So we know that W of a solute, which is basically 0.4 gram. W of a solvent is given, which is 100 kilogram, or I can say 100 multiplied by 10 raised to the power 3 grams. So I know that W of a solution will be equal to W of a solute plus W of solvent. Now I know that this solute is only 0.4 gram, but this will be 10 raised to the power 5 gram, which is very, very large. So I can simply say that will be actually equals to 100 multiplied by 10 raised to the power 3 grams only, because very small amount of solute is present. Now in this particular case, you know the amount of solute, the amount of solution. So this ppm will be W of a solute divided by the W of a solution multiplied by 10 raised to the power 6. That will be, we have 0.4 divided by 10 raised to the power 5 multiplied by 10 raised to the power 6. So that will be 4 ppm. Do we have any answer for ppm? Yes, option number D, we have 4 ppm. I hope this part is clear. Very simple question or very simple application related to ppm part. Okay, let's talk about another good question. A sample of drinking water was found to be severely contaminated with chloroform, okay, CHCl3, supposed to be carcinogenic in nature, cancer causing basically. The level of contamination was 15 ppm by mass, okay. So first of all, we have to understand the meaning of this ppm term, then we can proceed for the next part. Express this in percent by mass, okay, first concentration term, and determine the molality of a chloroform in the water sample. So first of all, we have given that the concentration is in ppm. So we have a 15 ppm. What is the meaning of this particular part? First of all, let's try to decode it. It means that 15 gram CHCl3 is present in 10 raised to the power 6 gram solution. Okay, that is the meaning of ppm. So if I am putting this 15 divided by 10 raised to the power 6 multiplied by 10 raised to the power 6 according to the formula of ppm, then we will get the value 15 ppm. So the meaning of 15 ppm is 15 gram of this carcinogen, which is CHCl3, is present in 10 raised to the power 6 gram of solution. So this is the first part and the most important thing which is required in this particular question. That's it. Now rest of the information is very easy. First of all, we know that W of a solute will be 15 gram, W of a solution will be 10 raised to the power 6 gram. So can we calculate percentage W by W? Yes, it's very easy. That is W solute divided by W of solution, 15 divided by 10 raised to the power 6 multiplied by 100. Formula, same formula. So we can say this value will be 15 multiplied by 10 raised to the power minus 4 percentage. That will be percentage W by W. I hope this part is clear. I hope this part is clear. First part, very easy. So first part is done. First part is done. Now the second part is determine the molality of a chloroform. Now the second part is molality. For molality, you know, we need number of moles of a solute divided by the W of a solvent in kilograms or in grams, you can take multiplied by 1000. That is the formula. Now in this situation, you know that W of a solvent will be approximately equal to 10 raised to the power 6, because you know that W solute plus W solvent will be equal to W of solution. This solution is very, very large with respect to the small amount. So you can say that W of a solvent, again you can compare it, is approximately equals to 10 raised to the power 6 grams. Because the amount of solute is very less, so you can say it is approximately same. Okay. If you want the exact calculation, then you can subtract 10 raised to the power 6 minus 15 and just let me know the final answer in that case. Okay. So now the next thing is number of moles of a solute, which we don't know. So that will be W of solute, which is 15, divided by the molar mass of solute. So now in this case, molar mass of CHCl3 will be equal to, we have one carbon, one hydrogen, which is 13, plus we have 35.5, we have 35.5 multiplied by 3. So I can say that value will be that is 15, 1, 15, 16, 106.5 plus 13. So that will be 919.5 gram per mole. Okay. So we know the value, which is 119.5. So number of moles are done. W of solvent is done. So we can say that molality will be equal to 15 divided by 119.5 multiplied by 10 raised to the power 6 multiplied by 1000. So you can say that will be 15 divided by 119.5 multiplied by 10 raised to the power minus 3 molal. Just solve the final equation and let me know the answer. Okay, or you can cross check with NCERT also, because this question is from NCERT. I hope the entire part related to molality ppm conversion is clear to everyone. Very simple question indeed and very interesting one. Okay, so just like that, you have to solve certain questions by your own. You can practice certain questions related to these conversions as well as to understand the basic idea of these type of equations. Okay, now next term is basically mole fraction. So it is basically the fraction of a mole. So I am talking about the comparison of mole with a mole. Okay, so in this case, again I am choosing a binary solution. Again we have a binary solution. In case of a binary solution, one part is going to be solute and the next part is going to be solvent, definitely. Okay, so in this case, I can define the mole fraction of these two components, which are solute and solvent. So mole fraction of any of the component is basically the fraction of moles of that component which are present in the entire moles of the solution. So basically in that case, you can define this particular part. Let's say we have two components A and B. Let's say. So first of all, the representation of a mole fraction is chi. We can define this entire part with the help of chi. This type of symbol. This is the representation of chi. Let's say the solute are having moles which are Na, solvent are having moles which is Nb. Okay, so you can say from that particular part that N total are basically Na plus Nb. Okay, now the mole fraction of A, which is represented by chi A, will be equal to Na divided by total mole, which is Na plus Nb, and mole fraction of B, which is chi B, is represented by Nb upon total moles, which is Na plus Nb. And always remember, for binary solution, this chi A plus chi B value will always be 1. How? You can put the value. You know that this will be Na upon N total plus Nb upon N total, which is equals to Na plus Nb upon N total. You know this entire part is already N total. So that will be N total divided by N total, that is equals to 1. So you can see that for a binary solution, chi A plus chi B value will always be equal to 1. It means chi A will be 1 minus chi B or chi B will be 1 minus chi A. I hope this entire part is clear related to the concept of mole fraction. Okay. Now, talking about the next part, I hope you all know these type of formulas. They are very easy. I can highlight the formula also for better understanding. So this is the formula. Okay. Now, talking about the next, okay, so we have question. Calculate the mole fraction of ethanol whose 4.6 gram is dissolved in 6.02 multiplied by 10 raised to the 23 molecules of water. Very interesting question. Very interesting question indeed. Okay, so what can be done? We have first component which is methanol and next, sorry, ethanol. It is ethanol and the next component is water. So I need both number of moles. So in this case, N of ethanol will be equal to W of ethanol divided by the molar mass of ethanol, because the information of weight is given. That will be equals to 4.6 divided by, in this case ethanol is having formula which is C2H5OH. If the formula is C2H5OH, it means we have 24 plus 30, 6 plus 30 plus 16, 46. So that will be 46. So this value is 0.1, first part. For water, we use the number of moles of water which are equal to number of molecules divided by Avogadro's number, because number of molecules are given. So we are going to use two different formulas of mole in this case. That will be 6.02 multiplied by 10 raised to the power 23 divided by 6.02 multiplied by 10 raised to the power 23. The actual value is 6.022, but for simplicity we are using 6.02. So that is equals to 1. So N total will be 1 plus 0.1, which is 1.1. Okay. Now we have to calculate the mole fraction of ethanol. So from that part I can say the mole fraction of ethanol will be N of ethanol divided by N total. That will be equal to 0.1 divided by 1.1, that is 1 by 11. Okay. So that is 1 by 11. I hope this part is clear. So I guess that will be equal to 0.09, I guess. That is option number A. Okay. I hope this entire part is clear. Very easy question, very interesting question, and you can practice certain questions from NCERT as well as NCERT exemplar. And if you have module, then you can solve the questions from modules. If you have DPPs right now with you, you can practice the questions from DPP itself. Okay. I hope up to that part everything is clear. Now next question is from NCERT itself. Calculate the molarity of solution of ethanol in water in which the mole fraction of ethanol is 0.04. Assume the density of water to be 1. Now this question is quite interesting, because very less information is given in this particular situation. Okay. So let's say, because you have to take certain assumptions in this particular case, then only you can solve this particular question. Okay. So calculate the molarity. So we have to calculate the molarity, which requires number of moles of a solute divided by the volume of solution in liters. Okay. And only in this case that X of ethanol is given, which is 0.04. If this value is that much low, it means solution is very dilute, because you know that X of water, the chi of water will be 1 minus 0.04, or I can say 1 minus chi of ethanol, because we are talking about the binary solution, that will be 0.96 from that particular part. So the mole fraction of water is very high, mole fraction of ethanol is very less. It means we have very dilute solution. First of all, the thing which you have to understand. Okay. Now the next thing, let's say volume of water taken is basically 1000 ml. Let's say I'm taking 1000 ml of water in this particular situation. So I can say that chi of H2O will be equal to number of moles of H2O divided by N total Okay, this value is given, this value is already given to us, which is 0.96. So I can say 0.96. Okay, what can we do? And total is already 1, so n of H2O will be 0.96, or I can say, okay, so if I am taking 1000 ml of water, I can say the density of water is also 1 gram per ml. It means that W of H2O will be 1000 grams. Okay, if it is 1000 grams, we can say that number of moles of water for this solution will be 1000 divided by 18, which is 55.555 basically. So this is the number of moles of H2O. Now what can I say? I can say that will be equal to number of moles of ethanol divided by number of moles of ethanol plus number of moles of H2O. That is the actual expression of mole fraction. From that particular part, I can say that will be 0.04 will be equal to this value, let's say is x. I am assuming this value is x. So x upon x plus 55.5. Okay, or if I want, I can use it as 1000 by 18 also. Okay, 1000 by 18. So that will be equal to 18x upon 18x plus 1000. Okay, from that particular part I can say that we have 0.72x plus 1000, that will be 40, will be equal to 18x. Okay, so 18 minus 0.72x will be equal to 40. From that particular part I can say that x will be equal to 40 divided by, so that will be 17.28. So x, we know that number of moles of ethanol are basically 40 divided by 17.28. I guess because that will be 18x plus 1000, 18 upside. So this is done. Then I have to multiply this 18x with 0.4, so that will be 0.72 for 1000, 000040 will be there. Okay, yeah, that is the number of moles of ethanol. We have calculated the number of moles by simply assuming that I am initially taking 1 liter of water. The sample of the amount of water is 1 liter, let's say. Now in case of molarity, you need number of moles of solute which are already given, that is 40 divided by 17.28. Now volume of solution, you know that we have a very dilute solution, and in that case the density of water we are assuming to be 1. So we can say that initial volume is going to be 1 liter only, because the amount of solute is going to be very less. So we can say that will be 40 divided by 17.28 multiplied by 1000 divided by 1000. So these are cancel out. So we can say the final molarity will be 40 divided by 17.28 molar. Okay, slight assumptions in this particular case, but otherwise the data is very easy to understand. So just like look at it carefully, then we will proceed for the next part. Very simple question indeed. Okay, now talking about the next part, we can say that we have certain relations. I am just showing the relations for your help, but just remember you can use 3 by 3 box trick, which is much more simpler. If you don't remember the formulas, you can use molality as well as mole fraction relationship, which is 𝐿𝐵 upon 𝐿A multiplied by 1000 by MA. So that is basically MA underscore A. Okay, not this particular part, MA. Okay, where basically 𝐿𝐵 and 𝐿A are basically mole fractions of solute as well as solvent. MA is the molar mass of the solvent. You can expand the formula of molality to find out the values in each case. So I can say that molality will be equal to number of moles of solute. So in this case, B is solute and A is solvent. So I can say this is NB upon W of A multiplied by 1000 if it is in grams. Okay, so what can we do? We can say that this will be WB upon MB multiplied by WA multiplied by 1000. Okay, now from that particular part we can say, or we can do one thing, we can say that this part I am multiplying with MA and dividing it with MA part. Okay, I am multiplying and dividing it with MA part. So that will be NB upon, so this particular part with this particular part, weight of solute divided by the molar mass of weight of solvent divided by the molar mass of solvent, that will be Na multiplied by 1000 divided by Ma. Okay, so this is the formula. Now you know that 𝐿𝐴 is equal to Na upon Na plus Nb, and 𝐿B will be equal to Nb upon Na plus Nb. So when equation 2 is divided by 1, you will get Nb upon Na plus Nb multiplied by Na plus Nb upon Na will be equal to 𝐿B upon 𝐿A. If you solve this, you will get that 𝐿B upon 𝐿A will be equal to Nb upon Na. You know this formulation. You have the same formulation. You can say that will be equal to 𝐿B upon 𝐿A multiplied by 1000 upon Ma. Okay, so that's the final expression. You can expand each and every type of expression by yourself. So this is one example. I already gave you one example related to molarity and percentage weight by weight. Okay, so in the same way you can relate molarity as well as molality. So molality will be equal to 1000 multiplied by molarity divided by 1000 into density minus molarity multiplied by molar mass of solute. So that is the formula you can use. If you are able to remember the formula, you can directly use it. If you are unable, then try to draw 3 by 3 box and write down the answer by yourself. Okay, in the same way, the relation between the molarity and mole fraction can be easily drawn. You can expand the formula and you will get the same part. Okay, in the same way, if I talk about the relation between the molality and percentage by mass, this formulation is very easy. That percentage by mass multiplied by 10 divided by the molar mass of solute will be basically the molality. Try to write down the formula by yourself and let me know if you are facing any issue. Okay, relation between the molarity and percentage by volume and percentage by mass. Percentage by mass we have already done, and percentage by volume is direct, just like the percentage by mass relation with molality. So it's very easy. Just remember each and every part. If you are able to remember it, then if you are not able to remember it, trick is very easy. Now you know all the tricks. Okay, now we have one more question related to the entire part. Calculate the molality of 15% solution by weight of sulfuric acid. Density is already given to you. Every information is given, so take it as your homework. Take it as your homework. Try to solve it by yourself and let me know the final answer. If you are facing any difficulty, just let me know. Okay, Next part is, okay, this question is very interesting. The mole fraction of solute in a solution is 0.1. At 298 Kelvin, molarity of the solution is the same as its molality. Density of the solution at 298 is 2 gram per centimeter cube. The ratio of molecular weights of a solute and a solvent. So, I am just giving you one simple hint. Don't look at the question. It is from JEE Advanced. It's very easy. If I am talking about the molarity, that is actually equals to molality. That's it. That's it. Try to expand the formula that number of moles of solute divided by the volume of solution will be equal to, in liters, will be equal to number of moles of solute divided by the W of solvent in kilograms. Okay, if you are taking this particular part in grams, that's also fine. So you can say that from this particular part, that NB upon volume of solution is basically W of solution multiplied by the density of solution will be equal to NB upon W of solvent. Okay, just try to expand this particular formulation and let me know the final answer. Okay, every information is given. Mole fraction of solute in the solution is 0.1. A mole fraction is given. If mole fraction is given, so it means chi b is given, or I can say chi of solute is given, which is basically 0.1. Chi of solvent will be 1 minus 0.1, which is 0.9. From that particular part, you can say that chi of solute divided by the chi of solvent will be 0.1 divided by 0.9. That's it, which is actually known as number of moles of solute divided by the number of moles of solvent. So that part is already given. So you can say that N of a solute divided by the N of solvent will be 1 by 9. And N solute and N solvent, you can expand the formulation, which is basically W of a solute divided by the molar mass of a solute multiplied by molar mass of a solvent divided by the W of solvent, which is equals to 1 by 9. Okay, so you have to calculate the ratio of molar mass of solute by molar mass of solvent. So you can say, if I am converting this part here and this part here, so we have molar mass of solute divided by the molar mass of solvent will be equal to 9 multiplied by W of solute divided by the W of solvent. So you just have to find out the value of these two. Everything is clear. This ratio will be clear to you. So this data can be determined from this particular part, that the molality and molarity are both same. It means, like, how can you explain this particular part? It's very easy. I am writing it here. I am writing it here, that the relation between the molarity and molality. The question says that molarity is equals to molality. Means, let's say same number of moles are present. So X moles are present in 1 liter solution. They are exactly present, X moles of solute are present in 1 kilogram solvent. That's the basic trick you have to remember. That's the basic trick you have to remember. Just 1 minute. Okay. Now, if this data is clear, you can say that 1 liter of solution will be equal to 1 kilogram of solvent. This is simple idea, but you can say that V of a solution from this part will be equal to W of solvent. Whatever values are there, they are exactly similar to each other. Now, from this particular part, you can convert the entire data because you need W of solvent as well as W of solute. W of solvent we have taken as 1 kilogram. How to calculate this particular part? We can say that 1 liter solution volume will be equal to density, mass by density. Volume will be equal to mass by density. Or I can say that volume we already know. Density is already given, which is 2. So we can say from this particular part, that in this case, present in 1 liter solution. Okay. Now, if this is 1 liter, we can say that W of solution from this case will be equal to 2 multiplied by 1, which is 2 kilograms. Now, 2 kilograms of solution, 1 kilogram of solvent. It means from this particular part, W of solute will be 1 kilogram only. Now, you know each and every amount. You can just put the value and let me know the final answer. So, very interesting question from JEE Advanced, but the question is very, very easy. Okay, just look at it very carefully, then let me know. Okay. Now, the next part is this question. A compound H2X with molar weight of 80 gram is dissolved in a solvent having density of 0.4 gram per ml. Assuming no change in volume upon dissolution, the molality of a 3.2 molar solution is. Now, this particular part is for your practice. Again, I am giving this question as homework. Now, you know the entire idea about the calculations. It's very, very easy. Just let me know and I know you can solve it. Okay. So, that's all for this particular chapter. We have discussed the entire part related to the mole concepts, the entire portion of NCERT, some additional concepts. We have discussed all the questions, almost all the questions from NCERT. Whatever questions are left, these are for your homework. Just practice those questions by yourself. Try to solve the entire part of DPP, and if you are facing any problem, just let me know. Okay. So, that's all from my side. Thank you so much.